Awesome stuff. Brilliant. Ooh, okay. Let's, before we crack on, do a little bit of a check-in. Hello, good evening, welcome. Thank you very much for coming. My name's Chris. I'm going to be hosting this evening's webinar and giving you a little bit of a presentation about agility and data science. Before we go any further, just wanted to check in. I'm really excited to be here. I'm very happy to be presenting to everyone across the US and across England and the rest of the world. So I'm really, really excited to be here. I've had a bit of a long day so far today. For me in the UK, it's 6 o'clock in the evening, so I've done a full day already, but I'm looking forward to it. What I'd really like is if we could all take a moment to check in ourselves. So what I'm going to ask you to do is to put into your chat window, don't send anything, but just type in how you're feeling. Are you mad, bad, glad, happy, sad, or afraid? Give me a little update on how things are going for you, and I'm going to just ask you to hold, don't send yet. Start your type and off you go. And what I'm going to ask is everyone to send a blast of how you're doing all at the same time. In 3, 2, 1, go. Bam, 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 bam. Look at that. We have James, who's feeling relaxed. We have Alexander, who's happy. Leanne, not too bad. Looking forward to a long weekend. Sounds awesome. Oh, we've got someone from Munich here as well. That's Ranjit. Hello there. Darren is chilled. Mohammed, who is feeling okay. Awesome, guys, girls, lovely to hear from you. Lovely to meet you all. Manu, hello there. Rika, hi, nice to hear from you. Balash, Jen is feeling energized. Brilliant, guys, lovely to hear from you all. Thank you very much. Okay, let's start off with a little bit of an introduction. So first off, thank you all for coming to tonight's webinar. Greatly appreciated. Before I begin, I want to say a few words about the Agile Coaching Group, who've been kind enough to ask me here to speak to you today. The Agile Coaching Group is a team of highly skilled and experienced Agile coaches and transformational consultants with years of experience in leading agility and enterprise work. They support startups, enterprises, individuals in the US, across the globe, and anyone who's aiming to create a thriving business. And they specialize in Agile consultancy, training, coaching, transformation, innovation, and DevOps. They have a bunch of upcoming courses and webinars which are definitely worth paying attention to. Those include the Place of Agility in Today's Financial Institutions, New Product Owners course, which includes elements on Certified Scrum Product Owner, Agile Project Owner Skills, and Jira for Product Owners. If this is your line of work, if you're into product ownership, you're an up-and-coming product owner, or indeed you're a product owner who's spent some time at their craft and wants to formalize their training, these are excellent qualifications, excellent courses to go on. If you're a part of a financial institution or you're looking to move into one before long, then perhaps the upcoming conversation on agility in financial institutions is for you. They're well worth checking out. So if that's your thing, I would absolutely take a look at that if you can. Now, as it happens, the Agile Coaching Group have been kind enough to donate 4 copies of this excellent book, the Agile Machine Learning book, with the subtitle Effective Machine Learning Inspired by the Agile Manifesto. They put 4 copies of this up for grabs at the end of the presentation, and I'll be asking 2 questions to anyone who wants to try and win a copy of that book. And you submit your answers by email. The winners will be chosen, and you might get lucky. Now, before we go on, there's one more shout out that really has to be done, which is to Yashandip, who is in Johannesburg and is enjoying a beer. I'm suitably envious of you. Perhaps we'll get one a little bit later. Okay, before we crack on, I've got the chat window switched on. Y'all know that. If you've got any questions that come up as we're going along, any contextual stuff you want to ask me, please shout it out. Please ping it straight to me and I'll try and answer straight away. If not, I'll take questions at the end if anyone has any. If as we're going along you want to do a screen grab, then please knock yourself out, have fun, do it. But I'd appreciate it if you could grab my contact details as well, then the bottom corner of every one of these pages, because well, I'd like to work with each and every one of you, given the chance. And you know, if you've got my contact details, then you can reach out with any questions or queries, or if you need any help or any assistance, or you've got any projects you want me to join in with, you can catch me there and then. All right, let's go. So this is me. My name is Chris Wolf, and initially I trained as an analyst and a software engineer. But It didn't take long before I realized I was actually better with people than I was with computers. So I moved into project management, and I was there as a digital project manager for 12 years. During that time, I worked for several of London's top agencies, and we delivered work for British Airways, Land Rover, Smirnoff, Unilever, Audi, and the 2012 Olympics. About 8 years ago, I discovered Agile and Agility, and I converted into following that line of career. And before long, I found myself working as a consultant Agile practitioner. Carried on working with a lot of digital agencies in London and delivered work for the NHS, which is the UK National Health Service. I delivered work for Tesco, which is a national shopping chain over here, feeding about a third of the UK at any one time. I also delivered work for Starbucks, Chivas Whiskey, and Square Enix. About 3 years ago, I started working for Shell Research, and they asked me to join them to set up their Agile practice, or at least assist in setting up their Agile practice for data science-led projects. In those 3 years, I've delivered data science projects using machine vision, natural language processing, linear regression, and process optimization. And these experiences have led me to the conclusions which I'm going to talk about today. It's worth saying that everything that I'm going to talk about today is emergent. It is very new, it's very cutting edge, but it is based on actual practical experience and my own experiences at that. So it is most certainly validated, and it's most certainly very, very real. There are 3 topics that I'm looking to cover today. There is established data science projects, or working with established data science projects, working with experimental data science projects, and the key differences you might come across if you run a data science project as opposed to any other sort of data science project, as opposed to any other sort of agile project you come across. Now, when starting to talk about these areas, I'm absolutely not going to be covering anything about how data science works or how to do data science. But do rest assured, you do not need to understand data science in order to support a data science project or to work as an agilist within a data science community. But nonetheless, everything that I'll be talking about is hugely, hugely practical. And we'll give you a whole bunch of tips as we go along to understand a little bit more about how you can work in those arenas. Before we go on, I need to baseline a little bit of knowledge and some of the key terms and phrases I'll be using. The first one is data science or data scientists. These are the folk who are responsible for analyzing, interpreting, and processing the extremely large amounts of data and large data sets that form data science projects. Their role primarily is to identify patterns in that data and use those patterns to create computational models that underpin the machine learning. The next group we've got are machine learning engineers. These people are specialist software engineers, and they're highly skilled in the integration of the data science models. Their role includes data handling, model output and interpretation, and developing the UI that will present the outcomes of the data process and the data models. There are some differences between an ML engineer, a data engineer, and an AI engineer, but for the purpose of today, I'm really just going to consider them all pretty much the same type of person, the same type of skill set. Next, we have machine learning. And it's worth noting that machine learning is now considered a more acceptable name of artificial intelligence. Following on from certain films where machines have developed their own intelligence and sought to take over the world, there's been a bit of a swing in the community away from AI and towards terms like ML or machine learning. That being said, machine learning covers all forms of machine-based computation, so machine vision, natural language processing, prediction, and all those other areas of artificial intelligence, or specifically now machine learning. And lastly, we've got a computational model. Now, a computational model is the part or the place where the machine interprets and learns. It is in effect the digital intelligence component of AI or ML. Technically, a model is a code-based representation of a mathematical model that is used to interpret complex nonlinear systems. It's often thought of in terms of a network of micro-decisions that, when taken all together, deliver a single conclusion with a certain level of confidence. And that description actually models the way the human brain works, that it is a network of micro-decisions. And this is very much where a lot of data scientists take their inspiration when trying to create models or trying to develop new forms of machine learning. Ordinarily, we just refer to it as a model, and that's how I'll speak from here on in. Now, when we talk about data science, there are actually 2 forms of data science. The first one is established data science, and this is used to solve common problems. It's typically available commercially. That is, you can go to a machine learning vendor and actually buy a model direct from them and get it off the shelf and effectively in a form that is ready to use. That means it's both pre-trained and highly accurate. And it's that way because it's been used to solve common problems. And because these are common, well-known, and relatively simplistic problems, it's possible for the vendor to highly refine that particular model and train it to a very, very high level of confidence. And in this respect, you can kind of consider it to be more akin to an engineering framework. That is, a set of tools, in this case models, that an engineer is able to take the necessary tools and join them together in a way that makes a new piece of software. In this example, a data scientist would be able to take many or several or just one of these predefined models, draw them together and combine them or use them in a data science project to achieve machine learning for your business. It's worth noting they can usually be altered to a greater or lesser extent before they get implemented, but on the whole, they are off the shelf and used exactly as designed. A good example would be facial recognition. Now, as much as there is established data science, there is also experimental data science. And this is where we start using new or emergent models. They are very often research-based, and that means they follow the scientific method. That really requires an awful lot of research, development of hypotheses, the experimentation to prove or disprove those hypotheses, and then high levels of refactoring before repeating the whole process again to develop new and further knowledge. Very often, experimental data science projects have a very close connection with academia, and they interpret and use lots of recent white papers. And that means it's very cutting edge. It means they're using new models that are only just coming out. It's very experimental. It's very uncertain. And it means effectively that they are using what can be considered unproven models, or indeed they're starting to develop brand new models themselves. And this means that when you're working with experimental data science, they are by their very essence highly experimental. And from an agile perspective, that makes them effectively unpredictable. That being said, experimental data science is really, really good for highly complex data, not just complex data that we see inside of established data science, but the really, really complex stuff. Imagine trying to map the sea floor and then interpret those results in order to find something very specific. Or imagine trying to compute the outcomes of seismic acoustic readings, looking for a very specific pulse or range of pulses, or indeed patterns in the pulses across a 200 square mile element of the seafloor. So that's the kind of things that experimental data science is for, the things that are effectively are so complex that you can't pre-produce a model, and you have to do something very specific in order to answer that question. So let's take a little bit of time to look at the established data science projects and what they're all about and how they work. First off, as I said, they are there to solve known and relatively common problems. That is, it uses models that have been commercially developed and optimized to solve frequent and clear problems. Typically, these involve the use of data science models that revolve around facial recognition, voice recognition, natural language processing, machine vision, and character recognition. And we see it an awful lot in things like biometric security, web searches, film suggestions that we get from Netflix or from Amazon, license plate recognition, which not only the police use, but we also see in a lot of parking spaces these days, and also for financial assessments and financial decisions to be made. What makes them appealing is that they are well-defined, well-built, robust, and trained on vast quantities of data. Now, as a result, that makes them really, really accurate, and the businesses can go to them and grab them and buy them and use them very, very quickly and very, very easily without having to do a lot of further training or a lot of further implementation. And this means that they are not only appealing, but they can be adapted relatively easily in order to be implemented into your business. We have a question from Kunle. Apologies if I've mispronounced your name. The question is, will there be a recording made available afterwards? Yes, absolutely. There is a recording being made right now. It'll be taken back to base, edited, trimmed, and then made available thereafter. So thank you for your question. If you've got any others, chuck them on in. Let's move on. Now, the next thing that's really, really valuable about working with established data science is that they operate, or the models operate, in well-known ways. And working in well-known ways means they bring lots of advantages, the strongest of which is the predictability. And not only do models behave in a predictable way, but they give predictable outcomes. And this means that data scientists, because they're working within known realms, are more able to give estimations for their work, more able to tell us a little bit more about how and when the work will be delivered. Got another question come in from Mohammed. Mohammed, do you want to come off of mute and just call your question out to make sure I understand it properly? No? All right, I will. I'll read out what Mohammed has said. Pre-trained models means old models. No, not necessarily. I'll cover a little bit more later on about what training means. In effect, consider it like this. When you develop a model, it starts off not knowing anything at all. It can't recognize anything. It can't do anything. It is literally just a mathematical model. You need to spend a period of time training that model to recognize something specific. So let's just say we wanted to use a video camera, connect it to an AI model, and the model recognizes when a person walks into our store. In order to do that, it needs to be trained on what a walking person looks like. And it needs to be trained with thousands and thousands and thousands of pieces of footage of what a walking person looks like so that it can identify a person. And that fundamentally is what training means and model training means. I can get into more detail later if you like, but fundamentally that's it. Consider it akin to training or teaching a child. When you teach a child to, let's say, write their name, they write their name hundreds and hundreds and hundreds of times, each time getting small improvements in what they're doing and how legible it is. It's exactly the same with a machine learning model. You present it with training data, effectively practicing, and you go over that data hundreds and hundreds and hundreds of times until the model self-develops itself, the artificial intelligence piece, to the point where it can recognize the data that you are presenting to it in training form. Once it's gotten to a stage where it can recognize the data you're presenting in training form, you can then start presenting data of an unknown form and say, do you recognize this? So if we're using the example of someone walking into your store, you should be able to present it with video footage of someone walking into the store, and it will say, aha, I recognize that. That's a person walking to the store. And equally, you can present it with the footage of someone holding an orange, and it will say, don't recognize that. It is not someone walking into the store. So that's kind of how that works. Hopefully that answered your question. And if it doesn't, please ping me another one. I had a note here that people are unable to come off of mute, so apologies for that. I've got an administrator working in the background. If they can make that change, that'd be awesome. If they can't, then I'll just read the questions out. Next question, does this also work for does this work when looking for anomalies, as in anti-patterns? Apologies if this is a noob question. Don't worry, no noob questions here. It sort of can. So in data science, what we're able to do is say search for known patterns, but we could also set parameters to say search for unknown patterns. We still need to say what those parameters were. So going to our example of someone walking into or out of the store, we could say, we're only interested in people who appear on screen this height as opposed to this height. This smaller height being an anti-pattern would be a child. We're not interested in a child. So we're only interested in people who are between these two heights and not a small one. So yes, you're able to ensure the data science can pull out odd questions, but they still need to be formed in terms of a question. You can't just say, tell me anything you think is strange. So if that were the case, looking at in our example of someone walking into the store, it would grab everything that is not someone walking into a store. So that could be a pushchair going past, someone walking past on the outside, a car going past on the outside, changes in daylight, when it rained, etc., etc. So it's actually quite broad to say, show me everything that is not. So it needs to be formed in terms of a question that data science can create a model that answers. So if you're looking for an anti-pattern, then you need to be able to define what that anti-pattern is. Another one would be able to ask questions at the end. Yes, absolutely no problems at all. Assuming we get the issue with muting taken off, then yeah, you'll be able to come on and shout me a question out, or you can post them straight into chat and I'll answer them in order and get through as many as I can. Right, that's all the questions I've got for the moment, or all the ones I've received. Let's carry on going. So we were just looking at the value of predictability. The other thing that's really, really good about working with established data science models is that Scrum works, and it works in exactly the way you would imagine. So that means it fits Scrum, it fits Scrum teams, it fits ML engineers, everyone can work in a very known way, and it can support, or the use of Scrum can support both the business and the team. And that means that all of the Scrum practices that we are very well aware of are well suited to established data science projects. So that is the stand-ups, the plannings, all of the other elements that we have, the estimation, and so on and so forth. They all work very, very well when you're in an established data science environment. However, there are some critical elements that we as Agilists do need to bear in mind as we go through this. First off, models need data, and this is absolutely critical. I've worked on way too many projects where we have developed a really good machine learning model, and it does exactly what we want it to, but we just can't get hold of the live data. And it could be because of a technological problem, it could be because it's in a black box environment, it could be because of business agreements or indeed international agreements, but not being able to get the data is probably the biggest point of failure on data science projects. So when you're working on these projects, ensure that you are able to get the data. Data scientists will need a phase in order to prepare the data, that is organize the incoming data, so it's in a form and format that the model is able to use. You need to define the accuracy up front. Now I'm going to talk a little bit more about what accuracy is a little later, so I'm not going to get into into that right now, but please bear in mind that when you're working with established data science, you do need to agree what the accuracy target is. And at the same time, you also need to start understanding what drift and retraining plan is. Again, I'll talk about what those are a little bit more later, but do bear in mind it's a thing that you need to get into. You also need to be very aware that it is awfully easy on a data science project to fall into silos and Agile. It is actually a real risk. And the reason it comes to light is that you very often have a position where the data scientist does their thing, they pass it over to the ML engineer, they do their thing, they then pass it over to QA and they do their thing. And it starts forming not only silos, but a waterfall process. So this can be very impactful because it impacts on the speed with which you can release. It also impacts on the value which is released, because the value can't be released until you reach the end when QA is testing, as opposed to, as we know and love with Agile, doing slices of work and releasing the value as you go. Another couple of questions. Adam has said, how does the updated Scrum Guide support or not data science? It doesn't. For example, product backlog needs a product goal, sprint planning requires a why, as well as a what and how. So the Scrum Guide is completely agnostic of the nature of the project that you're doing, whether it's data science or software engineering, or indeed if you were making a book or working with your team to migrate into a new building. So the Scrum Guide, excuse me, Scrum as a whole is very agnostic to the nature of the project that you're doing. What I'm doing in this webinar is talking about how we get Scrum to work in exactly the way we want it to for Agile data science. Excuse me one moment. Apologies. Next, we have a question from Douglas, who says, do you see multiple Scrum teams at Shell sharing their definitions of ready and definitions of done, and including those limits for accuracy? Okay, good questions. So showing your definition of ready and definition of done, in my experience, they are specific to each individual project, and they're specific to the workflow that your project has defined. That's particularly important here because there are different forms of data science. And the definition of ready and definition done you might have for, let's say, a machine vision project may actually be dramatically different to a natural language processing project. So they're specific to the project that you're doing. And do we share those limits in terms of accuracy? No, the accuracy is very specific to each individual project and the requirements of the business. And I'll cover that off a little bit more later. And Cecilia agrees with me. Thank you very much, Cecilia. Greatly appreciated. So we were talking about the critical steps in Scrum for established data science, and we just covered off the fact that siloing becomes very easy without much care when you're working with established data science projects. Now, that siloing can produce delays because we're delaying the value until it's passed through that chain, so obviously it's a bad thing. But there are a few critical causes why that comes out. The first of it, which is this drift and alignment between data science and machine learning, which I spoke about a moment ago. The data scientists do their thing, ML engineers do their thing, and it passes down a chain. We don't want that. This, however, is often caused or causes non-centric user stories. That is, stories that are focused on the output of a data scientist, output of an ML engineer. So it's awfully easy, and data scientists and ML engineers do this an awful lot. They start writing stories in terms of what it is they need to do. Produce a model that something, produce infrastructure that accepts the model, etc. And when they think that way, it's awfully easy to end up in that siloed position. What we need to do as Agilists is try to ensure the team stay on track with delivering user-centered value. And that's just the same as we've done with all of our Agile projects, and just the same as we've done with all of our other software engineering projects. It's just that when you hit data science, it suddenly becomes really easy to slip into those ways of working. It's something that we have to constantly push back against and constantly encourage our teams to stay focused on exactly what it is the customer needs the data science to do. Additionally, data scientists tend to deliver their working models much slower than the machine learning engineers. That's by the very nature of the work they do. And as a result of that, it can be very tempting to start using fake data. There's a time and a place for that. There's no problem with doing it, but just be aware that when you start using fake data, you end up in a position where things are slow and we are pushing testing until further down the track. Real world example. I was working with a group of data scientists, and they were building a system which was doing facial recognition. And they built it up there on their desktops, literally their physical desktops. So they sat there with a camera like this one. They were looking at it. Can it recognize my face? Get someone else to sit in front of it. Look at it. Can it recognize their face? Yes, brilliant. We've got a working model. The thing is, when we deployed it to a system where the security cameras were 16 feet up, looking at a down angle. So the angle that the cameras were looking at the face was totally different to when the scientists were training the cameras to look at the face. And because of that, suddenly the model stopped working in its entirety. We've been using fake data, and the fake data did not align to the real world data close enough. Not only that, in that particular example, because the security cameras were outside, we also found there were issues with different forms of light and different times of day and different weather conditions as well. So it's very, very critical that when you do use fake data, that you use data that is as close to real as is physically possible. So Google searches may not necessarily give you the sort of thing you need. You need to make sure that the fake data is as accurate as possible. The way I'm addressing that currently is by using sets of real data from a historical time period and then bringing them into my current project. So for example, we're grabbing data from December 2019 and bringing it into a current project, and we're using that data to form our fake data. And as a result, we're making sure that everything is very clear and very, very accurate. Douglas says he has a follow-on comment. No need to reply. Sorry, I'm here. If multiple teams are on the same project, for example, Scrum at scale, with a shared backlog and a code repository, I would think the definition of ready and done would be shared with them, but agreed for separate projects, fine to keep them unique. Yeah, nothing wrong with that whatsoever. Totally agree. It's all cool. Okay. So we talked about the fake data. So let's just move on. So yeah, just going to take a quick summary on established data science projects. So the summary is this. When you're working with established data science models, they are brought in pre-trained and ready to go, so they can be used almost immediately. They are used to solve common problems such as license plate recognition, and they require a data preparation phase to ensure all of the inbound data is ready for use. But they are well established, allows a great level of predictability in the project, which is hugely valuable to us as Agilists, so we are more able to answer the question of when will it be done. But as a result, this means that Scrum works particularly well with no adaptations and no real changes. But do be aware the pace of engineers will be greater than the speed of the data scientists, and the fake data approaches can be a viable way of working, but they do come with an element of risk. And lastly, accuracy targets need to be agreed at the outset of the project. So that's everything I really wanted to say about established data science. Let's move on to the experimental side of data science. Now, experimental data science projects are not the same as established data science projects. They're in fact very, very, very different. And treating them the same will lead to problems. Many of the issues that I find that data scientists or businesses or Agilists have stem from this single common misunderstanding. And this is crucial to realize there is a difference between the two. And because there's a difference, you need to treat them differently. So let's take a little look at why. Before we do that, just to remind us, this is what experimental data science is all about. It uses new or emergent models. They are research-based in nature, so they follow a scientific method. As such, they have research, development, hypotheses, experiments to prove or disprove those hypotheses, and then high levels of refactoring before repeating to develop more knowledge. There are often close connections with academia and the interpretation of new or recently released white papers, which means in essence, we are developing new models or working with unproven models. And this makes experimental data science highly experimental and highly unpredictable from an Agile perspective. But experimental data science is very good for complex data sets and very good for very complex problems. Let's take a little bit more of a look into this. Now, before we begin work on an experimental data science project, we need to make sure that all of our data is ready. The word data science says data first, so that's actually where we need to start. We need to start by looking at the data. And there are far too many projects that I've seen that dive straight into development, straight into trying to build a data science model without taking time to prepare or look at or investigate the data. And this tends to lead them into very, very challenging places. If you take some time looking at the data first or preparing the data first, you can save yourself a lot of bother. The first step is the data needs to be fully assessed before it's used, and you'll be a data scientist that does this. This allows a bunch of questions to be asked, like, do we have enough data? Is the data accessible? Is the problem solvable with the data that we've got? And do we have to build a prototype, or should we build a prototype in order to try to better understand whether our data is of the right form, format, and the right quality? As I've said, one of the biggest problems we often see with data science projects is access to the data. So actually answering that question at the very beginning, can we get the live data, can save you a lot of time and trouble if the answer is no, it's just not going to be there. Questions come in from Nathan. Have you seen more than just data science model role in data science projects, like a data engineer? Yes, data engineer, ML engineer, AI engineer. For this presentation, all the same type of individual. As I did a little bit of baseline on that earlier on. So a data engineer or an ML engineer is someone who is at heart a software engineer, but they specialize in data science projects and the application of data science and the integration of data science into the applications that they're building, and the specialization of being able to interpret the outputs of those data science models and present them in a human readable, usable form. So yes, they're all the same. Currently, I'm concentrating on the data science element because that's the most complex for us as Agilists. But yes, data engineers are very much a part of every single project. They actually build the application itself. So once you've looked at once you've done early assessment of the data, you then need to look at the quality of the data. So if the data is not appropriate to the question being asked, we're actually not going to be able to answer that question. If the data is all about sponges and the question is about apples, clearly the data is not going to be able to answer that question. So being able to understand it and check the completeness of the data, the time period that you've got data access for, and the relevancy of that data to the question you're trying to answer is absolutely critical. And again, this forms a stop point. If the quality of data is not high enough, the question will not be able to be answered by the data. So this is the moment where you just stop the project. Next, you need to do a bit of data preparation and try to understand what it is that the data looks like and how you're going to use it. And this is where the data scientists get their hands on the data, and they're able to store it, work out how to store it, work out how to organize it, clean it up to get rid of the data that isn't at all relevant, and put tags in place to assist with the training. Again, if the data can't be gotten easily or you're not able to work with it, this is the moment where the project gets stopped. So as you can see with those first three questions, we're able to save a business an awful lot of time, an awful lot of money if the answer is no to any of them. Next, we take a look at the problem itself. Experimental data science projects can actually take months or even years to complete. I've certainly been on one that took in excess of 18 months to reach its endpoint. So ensuring that we're actually asking the right question is pretty critical. This involves things like, is the problem clearly articulated? Is there actually value in solving that problem? Is this the right problem to solve? And can the problem be solved in a timely fashion? If we give an example of that 18-month project I was talking about, are we able to solve small chunks of it relatively quickly to release some sort of value or release some sort of confidence that we're going in the right direction or not? Important questions. Question, do I have approximately a percentage time that each phase takes? No, it varies entirely on the project, the question, the data. If your data has 20 million data points in it, it's going to take a lot longer to assess than if it just has 5 or 10 data points. I'm working on one right now where we have 20,000 data points that we're assessing just to see if the project can go further. This is where the data scientists come in. This is what they specialize in. They don't have to look at every single one of those 20,000 points to work out the answer. They have much better tools to do that. The point in question is much more give them the time they need to do this. And we'll talk a little bit more about how that works in a few moments. But in terms of time, I could just say that's not an agile concept. It takes as long as it needs to get the right answer. We are experts in ways of working and workflow, so it's to us to try and make sure that's as effective and as efficient as possible, not to define timescales. However, finger in the air, a couple of weeks should be enough. But that's why we do this phase. We say, hey, data scientist, here's a big chunk of data, assess it. Is this project going to go or not? And it's giving them the time to make that assessment before we actually start doing any coding. Next, we need to take a look at the accuracy of the data. And this is really quite important. So I've mentioned it briefly a couple of times. So let's give an example. If we're talking about a facial recognition system, then actually the accuracy that we need to achieve maybe sort of 70% is sufficient. We can recognize a face 70% of the time, or equally, we fail to recognize a face 30% of the time. And yeah, that might be acceptable. However, if we are looking at license plate recognition, then 95, 96% of the accuracy might actually be a little bit more appropriate. The police don't want a recognition system that actually can't recognize a license plate 30% of the time. They need a high level of accuracy. So understanding the accuracy at this early stage is pretty critical. It gives us our target point that we need to achieve with our data science teams. Now, if the first part of data science is data, then the second part is science. So this is where we start looking at science and what the scientific approach actually is. And the scientific approach is this. You hypothesize something about the data. You observe the data, then you hypothesize something about how the data could be used to answer a specific question. Once you've got those hypotheses, you then develop experiments that can be used to answer those hypotheses and prove or disprove them. Once that's done, you can draw a conclusion, make adjustments to your thinking, and then repeat the experiment. And the thing is, when we're working with experimental data science, this loop has to be repeated for every single avenue that we are looking to explore, or every part of the question that we're trying to answer, or every question they're trying to answer. And this means our data scientists can repeat this model many, 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 many times before it's considered usable. And they might repeat it many more times in order to drive the accuracy up to the levels that we need. And so we end up in a position where we are doing lots and lots and lots and lots of repetition. And the problem is, that could look a little bit like this. Now, this is just a binary system. That is, for every question, there are only 2 possible answers. And we can see within 5 loops, we've got 31 different possible outcomes. And a data scientist might be able to complete these 5 loops in 3 or 4 days. The problem gets more compounded if we are working with a tertiary system. That is, there are 3 possible outcomes. And in this example, you can see we reach 36 different outcomes in the space of just 3 iterations. Data science, however, is a little bit more like this. That is, there are an unpredictable number of iterations with an unpredictable number of possible outcomes. And the fact, it is a fact, well, this shows as a fact, that data science is actually not at all predictable. But Scrum relies on predictability to manage work in progress. It does this through velocity. After each sprint, or every few sprints, we look at what our velocity is and we say, this tells us how much work we can pull into the next sprint. And we pull that volume of work into that sprint, and theoretically, we do exactly that amount of work, and it exits the sprint. And this pattern repeats. So we're working in a predictable way. However, data science projects are not predictable. And they can't be pre-planned, and they can't be estimated. If you were to say to a data scientist, and I have done this, and said to them, hey, tell me what your next 4 or 5 experiments are and what the possible outcomes are so we can fit that into a sprint, they'll say, can't do it, sorry, I don't know. They can tell you about their current experiment. They could tell you what they hypothesis the outputs might be of that experiment. And they could probably tell you what experiments they might do next or what ideas they might try next, but they can't go any further than that. Because they simply do not know and they cannot see far enough in advance to be able to do that. And that leads us to the somewhat uncomfortable conclusion that Scrum doesn't and indeed cannot work for experimental data science projects. And I can tell you from experience, trying to make data science projects or experimental data scientists work in a Scrum way will fail. They start to squeak. They don't like it. They start saying Agile doesn't work. They start saying Scrum doesn't work. They start saying I can't work this way. And we start getting an awful lot of friction. However, as much as Scrum doesn't work for data science, it does work for data engineers, the ML engineers. So what do we do? Someone, Zachariah, has suggested maybe we should do weighted shortest job first because it removes the pressure from the techies. Yeah, potentially it can do. The challenge you have with that is you're trying to understand which job is the most valuable to do first. And that's cool with the techies, but right now we're talking about the data scientists who need to go through this process of experimentation and understanding and growing their knowledge in order to decide what it is they do next, because they're on an experimental journey of discovery themselves. Sorry, Sakharai's corrected me. Most valuable job first. And it's Zach. Hey, Zach, apologies. I've got your full name here. And again, yes, you're absolutely right. If you're working from a technical perspective, that can be done. That's not necessarily an issue. When you're working with a scientist, because they can't actually work out what jobs they need to do beyond the next one or two, then in order to make those sort of assessments on which one is the most important to do next, they kind of can't. It's a journey. Imagine it kind of like you're in a room, you've got a blindfold on, and you're feeling the steps out that you're taking in front of you so you don't trip over any furniture. You can't see or feel any further than the length of your arm. You can't predict what you're going to do next beyond the length of your arm. It's exactly the same with data scientists. They actually cannot see far enough ahead in order to work out what they're going to do in 2 or 3 steps' time. And that inability to work out, sorry, that's a really bad way of putting it, not inability, that unpredictability means it's very difficult to work or to compel data scientists to work in a Scrum way, which does require predictability. So we've reached this position where Scrum is bad for data scientists, but it's good for ML engineers. So what do we do? Well, this is what we do, Scrum ban. That is, we borrow from Scrum regular cadences, transparency, problem slicing, reviews, and stand-ups. All the things that we know, everything that we've got from our history, everything we've got from Scrum, it works. But these are all the business side of things, the regular deliveries, the transparency, the taking a big problem, slicing it into smaller problems, periodically reviewing how we're doing, standing up and talking. They don't actually solve the problem, they're ways of working. From Kanban, we then start borrowing things like stopping estimation. There's a thing data scientists weren't able to do. Stopping committing to dates, that's something data scientists definitely couldn't do. Using the end of iteration to review progress, as well as present work that is completed. Now that helps data scientists, again, because they're working in an experimental way, it can take quite a long time in order for them to say, I am done. But what they can do is take people on a journey to say, this is what I have discovered. This is where I'm at currently in my understanding. And the end of iteration from Kanban works very, very well for that, because there isn't a pre-committal that I will have X, Y, and Z done by this time. And that works fantastically well for data scientists who are unable to say exactly what they will have done in 5 days, never mind 2 weeks or 3 weeks or whatever your cadence is. So dropping those commitments, dropping the need to have things done by a particular date, dropping estimation, which is required in order to have a velocity-driven work in progress, and presenting work in progress as well as work that is complete really starts to support data scientists very, very well. Now, how do we actually go about doing that? First off, you split the teams. I know earlier you said watch out for the silos, but this time it's actually more appropriate. We split the teams. We have one data science team and one ML engineering team, or data engineering team, if that's the terms you're using. Both teams are working on separate parts of the problem, and that means we're able to break their dependencies by operating as 2 separate teams. The scientists work on the model, the engineers work on the APIs, the backend, data storage, front end, and any other ancillary features that are required. If you run both teams together, you lose a lot of apologies. If you run both teams separately, you're going to lose a lot of transparency and a lot of the understanding. So we need to address that. I'll think about that in just a moment. But what you will notice is that by splitting the 2 teams, we're actually able to use 2 completely different approaches, shown in the diagram just below. The data scientists are able to work using a Scrum-bound approach. The data engineers are able to maintain their Scrum approach. And by doing this, both teams are able to use a method that actually works better for them. And by running the 2 teams, you're also able to break any dependencies they have on each other. But it's absolutely critical they remain tightly aligned, although they are separated and loosely coupled. And to do that, you actually maintain a one-team mentality. So although the teams are separated, it's actually critical for us to ensure that they remain aligned as a single team. And to do that, we have one stand-up and everybody comes to it. The data scientists do their talk, and then the engineers do their talk after. And they each have their own board, and they each have their opportunity to talk and inform both teams about where they're at, what's happening, what they're doing next. And in this way, everybody hears the same message and both teams remain aligned. Both teams also have a shared cadence, and they have a shared review afterwards, or at the end of the cadence. They have a shared PO, and they regularly collaborate with each other. So what we're actually doing here is we've split how they work, but brought them back together to do that work. And we've kept them together as one team where it comes to talking as a team, delivering as a team, being with a PO as a team. So all we're doing is we're just separating how they work and nothing more than that, which is a little bit more gentle. We have a comment from Cecilia. She says, "Ha this disgruntled data scientist disillusioned with Scrum is me at the moment." I'm sorry, I feel your pain. I'm so relieved that I've said this. Thank you very much. Everything at our company requires experimental data science. I joined the company 6 months into a project. It seems to me that nothing has gotten done. 4 months down the line, I see why. I feel stifled and micromanaged. And if I push hard enough, I'll get a day in a 2-week sprint at most to familiarize myself with an entirely new system. I feel your pain. I really, really do. That's where this stuff comes in. Cecilia, feel free to ping me separately. If you need any support, help, or guidance, I'm more than happy to lend what I can. But, ladies and gentlemen, just listening to what Cecilia is saying there, that is exactly the antithesis to what I'm saying. That is exactly what I was saying a few minutes ago about if you force data scientists to work in a Scrum way, they will squeak. This is the squeak. This is them saying it does not work for me. Question, Ian, Scrum is all about experimentation. To think otherwise is just demonstrating a lack of understanding of Scrum. Yes. However, as Cecilia's just said, when you start talking about it in a data science context, Scrum doesn't work because Scrum, at its fundamental, is a framework whereby we limit work in progress and we limit to our velocity. In order to do that, we need to understand what we need to get done, have a view of what we can do for 2 weeks, and estimate that amount of work and pull it in. As we've been saying, data scientists can't actually work that way because what they're doing is too experimental. However, if you're talking about established data science, then you're absolutely bang on. Nathan, what role does the product owner play in a data engineering team, as most of the work is dependent on the data science team and it's exploratory? Good question. All right. So your PO does exactly the same job they have always done. And Ian's gotten lost. I'll come back to you in a moment. Ian, I appreciate you're lost. Could you just ping me where you're lost? I'll try and cover that one off. I'm also very aware of time ticking along. So what does the PO do for the data engineering team? Exactly the same thing they've always done. That is, they set what needs to be done, they set the backlog, they set the criteria, they set the deliveries, they set out the user stories. So, as an example, as a business owner, I want a facial recognition system that recognizes X, Y, and Z people to a high level of accuracy. And I also want a support system that delivers me data, tells me when the wrong people are here, tells me when there's a security breach, etc., etc. So the data scientists, so the data engineers are able to understand the ancillary functions they need to deliver, as well as take all the model, the data model from the data scientists and integrate it into the system. So apologies if that's a little bit brief. We're sort of down to 10 or 15 minutes. I do want to try and make sure we finish on time. Let's keep on going. So that's how we handle trying to pull data scientists into a position where they work or are able to work in a more agile fashion. At the same time as that, we've also looked at how we can continue to work with data engineers and keep them going in a way that supports them. So we've got systems in place now that support both teams to deliver a common understanding. The next thing we need to do is make sure we are managing our least value. In order to do that, we need to appreciate that ML engineers have a much higher level of throughput than the data scientists do. We covered this just a few moments ago. And the data scientists are less able to deliver at the pace that the engineers require. So how do we handle that? What do we do? How do we try and make sure everyone keeps working together? Well, the first thing we need to do is to develop very early on an agreed data model. And the data model is an agreement between the data scientists and the data engineers about what data is being presented, what data is being consumed, and the nature of that data. Once everyone's got a clear understanding of how that data fits together, the data scientists are able to go away and start working on the model understanding the model needs to deliver certain elements of data. The engineers are able to work on the application, understanding that the model will deliver certain types of data. And once you've got that understanding in place, and many of you will recognize that as the sort of the API model that we often use these days, both teams are able to operate in a way that they are not dependent on each other. And also, once we've got this data model in place, we are more able to set up a fake data approach with more accurate data that matches those requirements, and then deliver that into the data engineering system. And as a result of doing that, we decouple the two, and it means that the data engineers are able to go at their pace, and the data scientists are able to go at their pace. And so we've separated the two teams, and they're able to progress without jarring or holding up each other. Question from Manoj. Where does the role of data scientist fit in the roles mentioned in the Scrum framework? Close to PO or closer to the development team? So within the Scrum framework, we are supposed to be fairly agnostic of type of people and skill, because we are looking for T-shaped people. In this case, they are very, very much I-shaped people, and they aren't close to either the PO or to the data engineers. They're actually on their own. If we were to consider a line with data science, I'm trying to get my things so you can see them, data science, hardcore data science understanding on one end, hardcore business understanding on the other, data scientists are over here, POs are here, and the engineers are somewhere a little bit more in the middle. Next thing you need to do with your team is supercharge your transparency. Now, we do that very, very clearly. First off, we have two boards. That is one board for the data scientists and one board for the engineers. We have one single stand-up. We get everyone talking about what's going on, so we've got that massive amount of transparency. It's also very critical to get up and make visible your project vision. Where it is you're going, what you're trying to do. And that's critically important, because very often in data science, we have to slice that question up very, very thinly in order to deliver on it. So what you're working on right now, the current questions it says there, might actually only be a slim part of the overall project vision. So making sure the team maintain that project vision and everyone working on it understands that is very, very critical. Also, it's important to understand unit testing and define when that happens, because when a data scientist unit tests and when an engineer tests are two totally different times. So what we can see here is a representation of the way your boards might look. We've got data scientists, and they have to-dos. I'm going to look at my other screen so I can read more clearly. They have to-dos, things they're exploring, things they're building, things that they're testing, and then things that are ready for engineers. And then over on the right-hand side, we've got a clear statement of the accuracy of that element. So currently, what is the accuracy at? And what is our target accuracy? Again, thinking about facial recognition, the current level of accuracy might be 50%, and the target is 70%. So your board actually shows the rate of progression where you're at with your team. With your ML engineering board, you've got the to-do, WIP, and then data science testing. Yeah, data science bit fits in there. So when you're a data scientist, very often you can't test your work until it's been properly integrated. Yes, you can test it. Yes, you can make sure it's going in the right direction. Yes, you can show that the formula are going the way that is expected. However, until it's been integrated, you can't test it. So data science testing actually forms a part of the engineering process, and it comes before QA, and then you get the point of being done. And what you can see here almost is actually two boards which go like this. That is, you have a full Kanban process that shows the way your project goes from to do all the way through to done, and you are not recognizing your value until you are done. And you can see on that board, we've also highlighted the current question and your vision, or the vision of where you're trying to go. A note from Douglas: data visualization is crucial for communicating value. Absolutely right. Have you seen data visualization work, including cross-functional teams that you work with, or are they kept separate, maybe in communications design or marketing team? So by data visualization, I'm assuming you're talking about the output from the model. And very often the way we present that is in the end of the end of iteration, where your data scientist is able to say, here's what I've achieved, here's what I've delivered, and here are some charts that show that visualization, or some charts that show how our rate of progression is going. Hopefully that answers your question. Need to move on, still a few things to get through before we are done, and time is starting to run a little short, and everyone wants to finish up, I'm sure. Okay, so after we've supercharged our transparency, we then need to set the business cadence. That is, how often do we meet, what do we do, and when, so the business can understand the direction that we're heading. Engineers, I find, need to stand up daily. Data scientists, about 3 times a week is plenty enough, because their rate, as we said, is a little bit slower. What I found works very well for everyone is a 2-week iteration, and 1 planning session at the beginning and 1 review session at the end. As we've said, the review session is not just what is done, but what is our progress, how are we moving forward. So there's that constant release of value even if it's not an actual thing that is completely done. And last of all, it's worth considering that there are some new skills that data scientists need in order to start working in an agile way. And I appreciate what a few data scientists here. This is by no means meant to belittle you. This is just to recognize that data science is relatively new, whereas agility and engineering has been going for a while. And there are lots of things that we've learned along the way that are very, very valuable. So with that in mind, what we need to do is we need to understand, apologies, I had a message there, I completely lost my plot. This typically means that the experienced data science don't work on a single problem. When experimental data scientists look at how they work previously, they very often come from an academic background, and this means they typically have one problem they work on for a long period of time, and then deliver the solution at the end. Now, that isn't a terribly agile way of working. When we start incorporating these folk into agile ways of working, we need to start looking at things like slicing the problems much more thinly so we can release that value and understand our progress. We need to look at things like collaboration. Data scientists, typically when they're in an academic background, work on their own. So collaboration is important. Not seeking perfection, but looking for good is important. Slicing the problem to smaller slices is particularly important as well. Put another way, we can't assume that data scientists have the skill sets that engineers do and approach problems the same way that engineers do. So things like peer review can be completely new. PPE question, what is PPE? Personal protective equipment. So if we're looking at this diagram at the bottom, the question we're trying to work on is a person, and we're assuming a video is being taken or a photograph has been taken, and we're asking an ML model if this person is wearing the correct PPE. We might slice that problem down into several more achievable parts. That is there actually a person the model can recognize in the frame? Can we identify the upper body on that person? Can we identify if there's PPE, personal protective equipment, on their upper body? And specifically, are they wearing a respirator? These are all different parts and different models that are recognizing different elements of the question or resolving different elements of the question. And you can see from that diagram there that they're all progressing and they're all to a greater or lesser extent moving forwards. And there's a target of 70% that needs to be achieved, over on the right-hand side being 100% accurate, but 70% kind of in the midpoint is where we're trying to go. But what we're actually seeing here is not only is there a business question, but that question has been sliced down into smaller parts that we're able to answer using data science. We can also see the progress of each of those parts towards that target accuracy. And so here's a visual representation of what we're trying to do and where we're trying to go. I note, surprised to see PPE in the context of Agile. It's an example, trying to use a real world example that helps bring to life the need to slice projects down. So that's kind of everything I wanted to say about experimental data science and how, as Agilists, we need to adapt what we do and change our mindset and change our approaches in order to support data scientists. The final part of the presentation is just to take a look at the key differences between data science-led projects and the software projects that we more typically run. Skip over that one because time is tight. All right, so I started to talk about model training. This is a nutshell version of it. All models need to be trained. Doesn't matter whether they're established or whether they are emergent and new models, they all need to be trained. That is, they need to learn how to interpret the data they're presented with correctly. It's just that when you're working with established data science models, that's already been done. When you're working experimental ones, you actually do that as part of your project. Now, that being said, you will often find that even established models need to be trained or retrained depending on the nature of the data and when they hit the real world. And experimental models definitely need to be trained and retrained. And this is broadly how it works. First off, you start with a set of training data and you label that training data as to what it is. In the example we've got here, we've got cats, and we are clearly saying this is a cat. You feed that into the model starts learning, it starts adapting, it starts building those networks. And eventually it comes to a point where you give it a cat, it says, hey, this is a cat. The next thing you need to do is provide it with untagged data. That is, you provide it with a bunch of data that it has to interpret itself. And you know you've got a working model when it's able to say, this is a cat to that target accuracy. And if it's less than that target accuracy, you need to increase it. If it's over that target accuracy, you're doing good. Very brief form of model training. Forgive me if that's a little light. I'm very conscious of time, so I'm picking up the pace a little. Next thing we've said, we'll talk about this a couple of times, that is accuracy. There are 3 parts to accuracy. First off, a model is. So it considers right, wrong, true positives, false negatives, and true negatives. And is way more complex than we need to get into here. The point is, accuracy, and the minimum accuracy defines the lowest level that the business is prepared to accept for that model. The target accuracy, conversely, defines the performance level the business wants to achieve. So that's where you're trying to get to. The minimum is the lowest threshold. The target is where you're trying to hit, and you need to have some measure of accuracy for that. I should say there are lots of other forms of accuracy beyond R². That's just the typical one that data scientists go for. And your data scientists will be able to guide you in answering that question. It's also really important to understand that accuracy is related to value and to cost. That is, the more accurate a model is, the more valuable it is to the business. However, chasing target accuracy will lead to a longer duration and a greater cost because you are constantly investing in trying to improve that accuracy. To avoid this, we actually need to understand what the value of percentage improvement in accuracy is. And now by doing that, we can actually start assessing how we're moving and how well we're going. So if we were to consider the facial recognition system, and we might want 70% accuracy on that. If we currently find that at this moment in time, we're delivering to a 60% accuracy, and we're only improving by 0.2% on every iteration, we may find that we're investing $20,000, $30,000 every iteration, but it would take 5 iterations to get from 60% up to 61%. That's not necessarily a good return on your investment. However, if we're talking about an industrial plant and a 2% improvement on accuracy relates to $2 million of value, hey, you know what? We'll take those 0.2% and we'll carry on iterating and delivering a 0.2% improvement in accuracy. So it's really important not only to have a target accuracy, but to understand what the value of each incremental improvement on that accuracy is, because that helps you to stop chasing your own tail or spending loads of money trying to get to a level that is unachievable or just too expensive. Next, we need to take a quick look at what model drift and detecting drift is. So I'm going to read these out because these are the actual technical definitions of them. So model drift, also known as model decay, refers to the degradation of a model's predictive power due to changes in the environment and thus relationships between the variables. In other words, the moment you put a model into a real world situation, it will start to degrade, it will start to drift because the nature of the data changes every single day. Even if we believe we know what the data is, variations will occur, and these variations lead to drift. And drift is where a model moves away from the accuracy you delivered it at or the target accuracy. Detecting drift involves statistical change in the data. The best approach to detect them is by monitoring its statistical properties, the model predictions, and their correlation with other factors. Again, it's that target accuracy. When we put a model out, it has a certain accuracy. Over time, the model will degrade and will drift away from that accuracy. So understanding how far it has drifted, understanding how long that drift has taken, and deciding when you need to go and retrain the model to make it better with the current data is fairly critical. Next, the complexities of releasing, and guys, these are the last couple of slides. Next, we need to understand that in data science, releasing is a complex process. And this is one that has caught me out before. First off, you go with an alpha release. This is to test the accuracy of your model with live data and real world users. It is not a full release. It is getting it out there and seeing how the model operates outside of the lab environment. And the projects that I've had so far, and certainly the one I explained earlier, where we had the facial recognition from 16 feet up in the air, when we had the alpha release, we realized there was a massive drift and the model didn't work. That's why you have the alpha release. It's a known phase where you do not expect perfection, but you've got it out there and you're starting to see what it does with the real live data. And you're also able to collect examples of live data if you haven't had them before. Once you brought the model back and you've retrained it, you can then go for your beta release. And this is where you're testing model drift, again with live data, but you're doing it with a new and improved model, with the view that you may need to retrain it, but hopefully not too much. Once you've got the model out and it's performing at the level you believe it should be, you need to enter a period of run and maintain. And that is a cyclical check-in to test whether the model is drifting and what its current accuracy is. And that then needs to be done periodically. It could be every 6 months, it could be every 3 months, depending on the importance of the model. It could be every year, again, depending on the importance of the model. But the critical point is we expect drift. We have to incorporate that into our project. We have to incorporate that into our project plans or what we're doing with our team post-launch and ensure that the model is maintained and you have that opportunity to check for drift, and you have that opportunity to see if you need to retrain it. To conclude, first off, re-review what we have with established data science, and that is we are working with known problems, we're working with an agreed accuracy, and we have to agree a data model upfront, and run a data preparation phase. Scrum works very, very well, but we need to maintain alignment with our teams and watch out for silos. Be aware of delays in the delivery of value, because data scientists and data engineers operate at different paces, and plan for drift and retraining. When we talk about experimental data science, we are working with new and emergent models, and we're working in an experimental way, and experimental data science is not predictable. So Scrumban works very, very well. Use two teams, one for data science and one for model engineering, one with Scrumban, one with Scrum. But although you split the teams, we still deliver as one team. And again, the same as before, you need to ensure that you agree your accuracy upfront. Agree your data model, same as with your established data science model. Begin your data preparation phase. Run a full data preparation phase to ensure the project actually can continue. Upskill your data scientists where you need to ensure they have the necessary skills. Be aware of delays to the value for exactly the same reasons that data scientists operate at a different pace to data engineers, and plan for drift and retraining. We've run over, I apologize. I was answering some of the questions, hence the delay, but we are finished. What I'd really, really like to do now that we are done is, first off, I'd like to ask you guys how useful this session was. And what I've done is I've created a Jamboard where I will just grab the opportunity here, and I'd really appreciate it if you guys could give me your feedback. Let me know what was good, what was bad, how I can improve, so I can make this better and more relevant as time goes on. And then very, very lastly, if you want to win that book, here are your questions. What are the 3 types of accuracy? And what are the 2 things that need to be done post-launch? There's an email address there, answers@agilecoachinggroup.com. Send your answers over. Don't send your addresses to send the book to if you win. Just send the question. Make sure your email address and your name is there. Winner will be chosen, 4 winners in total, and best of luck. If you want to ask any questions, I'm going to stick around for a little while. If you're not, I appreciate we've overrun. We've answered a load of questions already. So thank you very much from the bottom of my heart. Really appreciate you taking the time to listen to me talk. And I hope there's been something here that's useful, and I hope your data science projects go well. If you do want to reach out to me, you've got my email address there, you've got my links in there. Please feel free. LinkedIn is probably the best place to grab me, because I get an awful lot of emails. Above and beyond that, have yourselves a lovely afternoon, lovely evening. Thank you so much. Bye-bye. Now, I'm going to drop over and see if there are any questions that come in. Rebecca, would it be okay to email me? Absolutely, yes, no problems at all. Jay Shargo, would it be okay to email a few questions? Absolutely, yes, no problems at all. Rebecca, I'm glad this was useful to you. Thank you very much indeed. Greatly appreciated. And everyone else is saying thank you, no questions. Awesome, awesome, awesome. Thank you indeed, guys. I'm going to hang around if there are any other questions, but otherwise, see you around. Will I send out the deck? I have to have a think about actually how to do that, because I don't have all your email addresses. So leave that one with me and I'll see what I can do. Best thing to do is watch out on my LinkedIn as soon as I've gotten to the bottom of actually physically how to do it without sending the physical deck to everyone. Yes, absolutely. I'll be more than happy to share it, but that's where the details will be. Thank you very much. Arun, I hope I pronounced your name there correctly. Yes, please do connect on LinkedIn. Looking forward to it. Thank you indeed. Rusty, thank you for the compliments. Really, really appreciated. Question from Peter. Do we create a new Kanban card for each iteration of the model? Oh, what a good question. Yes, so very often, you can, and B, you can choose not to. So let's look at each. You can create a Kanban card that says something, 2% accuracy, 10%. And that becomes your card, and you play it until you get to 10%. The problem with that is that card you'll find on your board doesn't actually change. It doesn't go away. It just sits there until you hit that 10%. And that doesn't give that feeling of progression or that feeling of constant delivery. So the way I tend to do it is I'll play one card till we get to a given accuracy. and then I play another card to get to another accuracy. And by doing that, you actually get to see that movement and that progression through your boards as you go. Otherwise, your board seems really, really stagnant, particularly if you are only increasing by 1% per iteration. Your target is like 10% higher. It takes you 10 iterations to close that card down. So getting that movement and that feeling of closure is really, really important for your data science teams. Thank you for the question. Will you share the recording with us? Yes, it has been recorded. The Agile Consultant Group have been recording it. Sorry, the Agile Coaching Group, apologies, have been recording it. As soon as they've edited it down, taken all the moments where I stumbled, they'll post it up. So yes, absolutely. Matthew, you'd be more than welcome to connect on LinkedIn. Thank you very much. I look forward to it. One from Thomas. My team and I have been programming, managing data science projects for many years, and methodology we've evolved over time is almost exactly the one you've described. Uncannily so. I got it right. It has worked extremely well for you, Thomas. I'm super, super pleased that the method works for you. Really, really glad. The fact that we've ended up with the same conclusion completely separately actually makes me very, very happy. Because this is very, very emergent and it's very, very new. You go into every data science project not necessarily knowing if the way you used it last time works this time. So the fact that you've said the same thing is really, really great to hear. Thank you very much. Peter Graves, perfect. That helps. Can't agree more than on ML engineering. Don't like doing Scrum. Leave us alone. Yeah, I know. I hear where you come from that totally. Thank you very much. Appreciate it. Right, so that takes us sort of 15-ish minutes beyond the end. If anyone's got anything else, do let me know. If not, do feel free to drop off and go about your business. Question from Rusty. What is one of the best ways to help Agilists let go of the data scientist? There's an interesting one. So I interpret let go as in give them their head as you would a horse, let them do their thing, let them go at their pace, let them move forwards the way that they want to. You know what? Trust. They are clever, clever folk. One of the teams I'm working on at the moment has 3 PhDs on it. They are properly smart people, way smarter than I am. Literally, I cannot fathom what they do, and I don't try to, and I recognize that I don't try to. So for me, it's about saying, guys, you go ahead and you do what you need to do. All I'm going to do is put a framework in place that supports the way that you're going to work. And that framework we've already discussed is the Scrum Band thing. But by taking away their problems, so you take away the estimation, you take away the commitment, what you're doing is creating an environment of trust, an environment where they can start performing and hitting the position of being a high-performing team. You're actually developing psychological safety for the way that they work. So continuing to build that is absolutely critical. And it's just the same as if you're working with a data engineer or a software engineer or a QA or anyone anyone whose capability exceeds our own as Scrum Masters and as Agilists. And frankly, I go into every team believing everyone is better at what they do than I do. There's no way I can supplant their knowledge. My job is to provide a framework, provide a way of working, and to ask probing and smart and deep questions to ensure that the teams are self-questioning what they're doing. And if you do that, you stop trying to lead the data scientists and you let them do what they need to do. And Rusty says, yes, very much the case, and respect. Absolutely, Rusty, you're right. Respect for the data scientist is critical. Or he suggests make a Scrum Master, a data scientist for a day. No, please don't. My math isn't that good. I remember when I first started working with data scientists, I decided I need to understand this thing. So I started studying it and researching it. And I came to the point where an article I was reading was trying to describe how to mathematically prove the lowest point on a 3-dimensional graph. And you know what? I closed my book and I said, you know what? That ain't for me. I can't do this. That's beyond me. And that was a really important realization because it meant I had to trust them. I was compelled to trust the data scientists. I can't do their job for them. I can't tell them how to do their job. I can't tell them what model to do or how to work with Jupyter notebooks or how to program in R. Can't do it. I'm just not that smart. I'm really not. But that means I have to trust them. And that's a critical skill. Rusty says, walk in their shoes, slow the conversation down. Yeah, what they do is difficult and it's complex. And you see that when you ask them to demonstrate where they are at the end of an iteration, they're looking good. You want me to do what? Because very often the work that they are delivering is almost unpresentable. It can be presented as a series of graphs and charts and dots and things that they understand and scientists understand. but the business won't understand it and the PO won't understand it either. So that the greatest tip I've had for that from a data scientist is to explain it to your mum. So if you can describe what's happening in a way that your mum would understand, then you'll hit the right point for describing it to the business. You'll be able to present to the business where you're at. And I know I've reiterated it a few times, but it's really important not to say to a data scientist, that's the end of iteration, you've got to show me done work. You show the work that is ready to be shown. Whether it's done or in progress doesn't matter. And one of the things I find is that because data scientists can take a very, very long time, they could work on one problem for multiple sprints. Let's say it takes 5 sprints, 10 weeks. You don't want to wait to the end to see what's done. You want to see that continuous delivery of value. And the delivery of value may not be a working model. It may be we're getting better. We're recognizing more. We're seeing patterns. We're able to now demonstrate, and this is a real one that I had, we're now able to demonstrate that we do not have statistical bias. That's a really important thing. Get up there, show your PO that that's what you've discovered. Show your PO that that's what you're doing now, that's what you're doing next. So actually getting that conversation out and slowing the conversation down to the pace the data scientists are working at, really, really important. Rusty says, it must be a very good skill to be able to come to trust the things we do not understand. That's critical in my role. Everyone out there is way smarter than me. I may have started as a developer, but they start talking about Kubernetes now, and I go, yeah, great. I know what it is, but I've absolutely no idea how to deal with it or how to make it work or how to fix it if it's broken. I have to trust that you guys know what you're doing, and you have to go into it with that trust. Healthy dose of skepticism, because as Agilists, we're the ones who spot problems before they occur. So a little skepticism is required, but fundamentally, you've got to trust your people. And last one from Rusty. What to prove you know your stuff? Explain it to an 8-year-old, and then you can go and sell it. Yeah, explain it to your mum, explain it to an 8-year-old. Use lollipops, that works as well. So yeah, love it. Good points, Rusty. Thank you very much indeed.